right, guys. So unit 6, again, we're talking 2 populations now instead of 1. Remember on your calculator when you go to test how you have all those other choices, like 1 proportion, Z interval, 2 proportion, all of those 2 sample, 2 proportion, that's the stuff we're doing this unit, okay? So we're going to try to get through the population stuff today, and then we'll save the mean stuff for next time, okay? And I mean the proportion stuff. Wow, words. Do this. All right, so first we've got some formulas here if we're dealing with proportions. The mu of the difference in your 2 p-hats is the same as just the difference in your 2 population proportions here. Let me show you what. Sometimes you'll be analyzing this and you won't know your sample proportions, but you will know the population proportions. So you use P1 and P2, not p-hats. To remind you of what this is related to, back when we did 1 sample proportions, the mu of p-hat was p, and the sigma of p-hat was the square root of p times 1 minus p over n. You guys remember those? Mu of p hat and then sigma of p hat. So you can see when we have 2 proportions here, it's very similar. You're just adding in a whole nother p value there, like another proportion. So you've got your first proportion, your second proportion. That's all we're doing. We're combining right now, okay? And when we had 1 sample, our conditions, I'm really not right today. We're going to make it, guys, I promise. You had n times p had to be greater than or equal to 10. N times 1 minus p had to be greater than or equal to 10, and we wanted to see a simple random sample. The difference here, when you have 2 proportions, you have to check for both of your populations. So the 2 groups you're trying to make a comparison between, you have to go through and check conditions for both of those. So that is a little bit tedious. And also another difference, you have now n times p has to just be greater than or equal to 5, and n times 1 minus p greater than or equal to 5. When you're doing a 2 population type of problem, that's your condition for normality with proportions. All right, then one that is new that we're going to start checking this unit as well is independent samples. We want to make sure that our samples are taken, like that you couldn't possibly end up in both samples, okay? So totally different groups that we're sampling from. So your populations must be separate. And then the 10% rule here, I'm still not going to be checking that like when you do free response for me. But you guys have seen that come up several times on your Khan Academy assignments, right? Checking independence, is it less than 10% of the population? That's all that's talking about. So again, we're not going to do it on our free response, but just so you're aware that it's out there when you're doing your practice problems. It's a heavy sigh already.
I thought that, so they have to be independent, like 10% of them can be non?
No. Okay, so you're going to have 2 different populations that you're dealing with. Okay, you're trying to make a comparison between these 2 populations, like, I don't know, Madison students and Langley students. You wouldn't want someone to be in both of those populations. Okay, like if you did something like 9th grade students and Madison students, there could be an overlap there. Those would not be considered independent. Okay, so it's got to be 2 totally separate groups that you're looking at. You wouldn't want to sample someone who actually came from both groups. Okay, does that make sense? And then the 10%, that's just saying whatever your sample size is, needs to be less than 10% of the entire population. So if the whole population is only 100 students and you sample 50 of them, that's like, that doesn't work. Does that make sense? Okay. All right, we're going to be making confidence intervals in this unit as well. So again, let me remind you when we did confidence intervals with our one proportion. We did a one proportion Z interval. And that was p hat plus or minus your critical Z value times the square root of p hat 1 minus p hat all over your sample size. Which again, you can see when we do the interval here with the two proportions, the formulas are very similar, but you just now have two different p hats that you're dealing with, two different sample sizes that you're dealing with, okay? And once we get to an example, you'll see how you plug in all of those values. And your calculator will do a lot of the mechanics for you. And then when we did one proportion Z test before, your Z was always p hat minus p over the square root of p times 1 minus p all over n. Now we're doing a two proportion Z test. Is it what?
That's all right.
You sure?
Yeah, it's one problem. And I was just sure.
Okay, yep. Proportions are a little easier in that you don't have Z and T to worry about. You only have Z's to deal with.
So for all the problems in this unit, we'll do all of these calculations.
They're all things that could be asked. I might ask you to make a confidence interval, or I might ask you to do a hypothesis test, or a sampling distribution type problem, like any of those. I won't necessarily ask you all three of these like in the same question.
Okay.
I could, but not necessarily, okay? All right, we okay so far? We're still alive? All right. And then the other thing we're going to talk about here before we get to doing some examples is when we pool our data. Pooling. Okay, this doesn't happen all the time. This only happens is that if your null is that the P1 equals P2. Okay? Other ways you could write that. So we've got P1 equals P2 for your null. Or you might see it as P1 minus P2 equals 0. That means there's no difference between the two proportions. Or you could see P2 minus P1 equals 0. So all three of those are situations where you would be doing a pooling type problem. Okay, and this happens when you're not told what each proportion is individually. Again, that's why we're pooling them together. So you're trying to find an estimate based on those two things being combined. And again, this is like the why we need to do this. You know what the difference is between the two proportions, but you don't necessarily know the individual values, okay? And you have this lovely formula for p hat combined. And we'll do an example where we walk through that. All right, then we're going to skip over the page on means. We've got a couple of pages on means, and then we're going to get to skip mesh pairs T. We'll get to our first example, guys, okay? The goal today is to get through all the proportion examples. Let's see how we do. So this is the one we're starting with. Sampling distribution problem. You guys remember sampling distributions back from like the unit 2-3 stuff? It's been a little while. Yeah, okay. So we'll go through this again. The actual calculation part of this does not take very long. What takes a really long time is all of the define the parameter, check all the conditions for both populations, write out everything that you know and don't know, all of that. That's what takes a long time with this, okay? So let's start by defining our population. So we've got proportion of boys at Madison who dress up for Spirit Day and the proportion of girls who dress up for Spirit Day. And we've got our random selections of these two groups. What is the probability that the proportion of girls who dress up for Spirit Day, and I think this wording is confusing, is less than 0.08 more than the boys? Do you agree that you're like, wait, less than, more than? It's saying the proportion is smaller than 0.08 more than the boys dress up, okay? So they're saying they dress up more than them, but in a small proportion. I know, it's kind of tricky. Let's go through the steps. We need to define the two populations. So I'm going to say P sub G is the proportion, and you can abbreviate, of JMHS girls. And I'm going to just go like halfway across here. That dress up for Spirit Days. And guys, what is that? What do we know is the proportion of girls at Madison that dress up for Spirit Days? 0.75, good. So we know that true proportion, okay? What is our sample size for the girls?
40.
Good. What about P hat for the girls? Do we know P hat? We do not, okay. Don't know P hat. All right, let's go through that same stuff for our other population. What's our other group? Okay, so the proportion of JMHS boys. That dress up for Spirit Days. All right, and what is the true proportion of boys that dress up? 6'5". What about the sample size for boys? 55. Okay, and do we know P hat for boys? No, we do not know that. Okay. Good so far. None of that's really too tough. It's just tedious, right? Just have to write it all out. Okay, now we get to check conditions for both of these groups. All right, we'll start over here on the girl side. So for normality, what do we use? What do we check that with? Yeah, yes. Exactly, yep. And so since we have these two different populations, we have to make sure we label it. So N sub G times P sub G, which would be our sample size of 45 times our proportion of 0.75. That comes out to 33.75. Definitely more than 5. And then we also have to show N sub G times 1 minus P sub G. So that's 45 times 0.25. And that is 11.25. Also greater than or equal to 5. Yes, you have to use the subscripts. Yes, you have to show all the numbers, what you're calculating. Think of it as free points, okay? You can check these conditions and get the point for this on your test, even if you're not sure what the process is, what test or interval or anything you're doing. You can get this free point, okay? All right, what other conditions do I need to check? Yeah, let's see, SRS. Was it stated? Is it assumed? What did they tell us? Yeah, it was stated. They said we took a random sample. Okay, and then the one that's new is independent. Do you think these two groups are independent? Yes. We're going to go with yes, that these are separate, okay? Can't be in both groups. Yes. Yeah, they should always be independent. Like, it would be an odd problem that you're like, no. Yeah, so, but you still have to just like check the box for it, okay? Yep. All right, then we're gonna do those same conditions for the proportion of boys. They're gonna be super similar other than the numbers when you're doing the normality check. Yeah. Just something about, yes, they're independent because you can't be in both populations, whatever groups we're talking about here, okay? So our normality on this side, this time N sub B times P sub B. What was our sample size for the boys' side? Yes, we've got 55 times, what was the proportion? Yes, 0.65. That is 35.75. Definitely greater than or equal to 5. Then N sub B times 1 minus P sub B. So 55 times 0.35. That comes out to 19.25. also definitely greater than 5. And the random and independent will be the same on both sides. Okay, so SRS was stated. Independent. Just something about yes. Can't be in both groups. At least for our problem today. Okay, so you've got all of that stuff that really has nothing to do with the actual calculation of the problem, but you have to show it on your free response, okay? Any questions over the conditions or defining it? It's not really much new. It's the same process. You just like get to do it twice in one problem. I can tell you guys are very excited about doing all of that twice in one problem. Try to rein it in a little. Okay, so let's do the actual sampling distribution part now. So our notation here. So we're going to start with mu of p hat sub g minus p hat sub b. Now, we don't know our p hats, do we? So we don't. So we're going to say, yeah, exactly. It equals p sub g minus p sub b. We're talking about the difference in the proportions here between these two groups. So what was p sub g? 0.75 minus what was p sub b? Good. So we're saying the difference between these two proportions is 10%. That's what that part is telling you, is that girls dress up more than boys 10%. All right, then we have our sigma of all of this. So our sigma of p hat sub g minus p hat sub b. And guys, as far as the order, like girls minus boys, but boys minus girls, it doesn't really matter. You just kind of want to define that at the beginning and be consistent when you go through it. The question asked about girls dressing up more than boys, so that's why I started and did girls minus boys. Okay, but you can get the right answer doing it in the other order too. All right, so let me write the formula for you again. It's a nice one, nice large formula. P sub g times 1 minus p sub g all over n sub g. So you've got that whole thing like we were doing before with our proportions for the girls. And then we add to it p sub b, 1 minus p sub b, all over n sub b. It could happen. No, you could just make it one fraction with the combined denominator and add the numerators if you wanted. Like, so it's only one fraction instead of two, but other than that, it doesn't really make it simpler. It seems like it should. It doesn't. All right, so we're actually going to plug this into our calculator. So let's think about what our values are. I'm going to write it out with the values in just so we can see them. P sub g was 0.75, so 1 minus that would be 0.25. And the sample size for girls was, I think, 45 plus, so 0.65 with P sub b. 0.35 over 55. All right, guys, try keying it in. Let's see if you and your calculator are getting along today.
do you have to like do these steps on the actual thing, or is there like a process that's like
So, because this is a sampling distribution problem, there's not tremendous shortcuts. When we get to the confidence intervals and hypothesis tests, you will not have to do this stuff like this.
okay.
On your phone.
I didn't read that.
I did not sign up to push that many buttons. You can do it. No, you can. Huh? Oh, question? Yeah, I was like, wow, that's quick.
Yeah, so is the owner the same person as the manager?
Yes.
Okay.
That's really weird though, that we did that. So you're the only person that. Yeah. All right, anybody got anything for me? No? What'd you get, Mia?
0.09.
All right, I'll just go 0.091. Are we okay with 0.091? Yeah, go ahead. Okay, that's not our answer yet, guys. That's just our sigma of the difference in our p-hats, okay? All right, let me draw a picture now for what we are talking about.
Wait, Miss Lee, what does this number mean?
This is your sigma. So do you guys remember doing normal CDF and you have to put in like your minimum, your maximum, and then a mu and a sigma? That's what we just found were the mu and the sigma that we're going to plug in. So let me draw the picture and write out what you actually have to do to find that area. All right, so we're going to draw a little picture here. Where do you think this is centered at? Any thoughts? Where's my picture centered? What did you say? 0.1, yes, right? Wasn't that our mu up here? Mu of p hat sub g minus p hat sub b. That is 0.1. Put 0.10 if you really want to. Okay, and then what did the question ask us about? What percentage difference are we looking at? Yeah, so less than 0.08, more than the boys. That really confusing wording at the end of the question, yeah. That 0.08, are we okay with the 0.08 would go over here? Okay. They're asking us about the difference in the proportion being less than 8%. So shading would go this way.
So is the 0.08 for exponent?
It's just, it's just like the value we're cutting it off at. Sampling distributions, I think, is the hardest unit for you guys. And then when we revisit it again, it's like, wait, what did we do? Because the confidence intervals and hypothesis test, I think, is more straightforward for you. This, you're like, what am I doing? This is that whole repeated sampling over and over. How likely is it to get a sample? The what? It's just tough. Yes, there's.
It kind of like after we take the test, it kind of just like blurs together.
It's fair, yeah. But we're going back to all of it in this unit. So that's what I was saying. This unit is kind of a big unit for you, okay? So we'll get through just the proportion part today. And then you'll see it again with means. We'll get there, guys. So with a sampling distribution, what I'm trying to do is I'm trying to find this area. That area, that shaded area, is the probability of this happening. So how do I find shaded area? What do I use on my calculator? What did you say? That's essentially what the 0.08 is, although we haven't normalized it yet. Because yeah, we're going to do the normal CDF, okay? So based on the picture I drew, where am I starting? Like, what's the left? Yep, negative infinity. I'm starting to write 0.08. Negative infinity up to your 0.08. Then what comes next? Mu, yeah, and it's not just mu, it's mu of the difference in these p-hats, okay? It's that 0.10. And I'm gonna write this down below where I have more room because I need to label it too. So. All right, so negative infinity, 0.08. 0.10, and we want to make sure we say that's mu of p hats of g minus p hats of b. And then what's the last number that we use in here? Sigma, yeah, so that was what we calculated to be the 0.091. So that was sigma p hats of g minus p hats of b. Hopefully you can read yours better than mine. All right, guys, so try keying that in. Let's see what we get. You guys remember where normal CDF is? Distribution menu, so second bars. See it? What'd we get? 0.413, good. All right, we okay? Now we get the thrilling conclusion of writing our contextual, let's see. All right. I know, and I tried to give you a little more space on this one. I gave you the full page, but I know it takes up a ton of room. All right, so what this means is that there is about a 41.3% chance, or likelihood, we'll say, likelihood, that a simple random sample, so that an SRS of 45 girls and 55 boys at JMHS will result in the proportion of girls dressing up for Spirit Days is less than 8% more than the boys. So again, super weird wording on this too. Okay, Ethan. Running out of lead over there. Is there something you can't read?
Is it
Less than. Should be less than. That doesn't make sense. There you go. It's right. Yeah. Stay hydrated. All right. How do we feel about that conclusion? I know, it's like we did so much. And then you write this. And so much of that is just the context of what your sample was. So with your sampling distribution, remember you're just talking about how likely it is for this to happen, okay? And really you're going to pull most of it from the wording of the question. All right. Okay, let's turn the page and try, I think we've got a confidence interval next. I think you'll like this one better. I know I gave you less room, so it's a little bit shorter. I was able to, I did it by hand first, and I fit it in there, but I write fairly small, so if you write large, you're going to run out of room in there. Yeah.
How will we know like what to do what calculations?
So that is interpreting what the question is asking. So let's look at like our different options. So that was sampling distribution. This one's 2 proportion Z interval. It's obvious when you should do a confidence interval because it just says construct a 95% confidence interval. Like you know that one, what that's wanting you to do, okay? But let's read, I know we're not going to do this one next, but read the hypothesis test too. So do you see how this says, is there significant evidence? That's your clue, like, oh, I should be doing a hypothesis test, okay? So you really just have to like look in the wording for what it's asking you to do. Whereas the sampling distribution one, it just says like, what is the probability or how likely is this to happen? That's when you know you're looking at just a sampling distribution problem, okay? All right, so let's do our confidence interval one. Okay, so now we're doing a study over at Langley, and we've got different samples. We're still sticking with dressing up for Spirit Days, apparently. And we're going to construct a 95% confidence interval for the difference in proportions of girls and boys who dressed up for Spirit Days at Langley. So we have to start over again with defining all of those things. I'm going to use the space up above as well, just because I will probably run out of room on this slide. So what is P sub G going to stand for this time? Yeah, so proportion of girls who dress up for Spirit Days at Langley, or proportion of Langley girls. All right, do we know P sub G? What do you think, Luke? So is that the true proportion of all girls at Langley? Yes, there you go. I tricked you unintentionally. So we don't know P, but we know P hat. So P hat sub G That absolutely is the 127 over 210, which I think is about 0.605. Okay. If we knew the true proportion, we wouldn't have to construct the confidence interval. We would already know what the true proportion is. Remember, the whole point of a confidence interval is to try to capture the truth within that interval. We know the truth, it's very easy to capture, okay? So here we're just basing it off of our sample. All right, so now let's do the same thing for P sub B. So this is the proportion of Langley boys. Dress up for spirit. So again, we don't know P sub B. We do know P hat sub B. What's that? What is P hat sub B? That's the 118 out of 200, which is the 0.5. Okay. With me so far? Okay. What do we have to do next? Define what? Sorry. I still ain't hearing the. We're pretty good with that. With the just we don't know P. We've got P hat. N you really see in there. You could list N sub G and N sub B if you wanted to. What's the other thing that's pretty tedious to do that we definitely have to do twice here? Yes, conditions. Let's do those next. Sorry. Okay. Yes, we have to write out N sub G times P sub G, which really should be P hat sub G this time. So that's going to be 210 times our 0.605, which we know is 127, definitely greater than or equal to 5. N sub G times 1 minus P hat sub G, 210 times, thanks, and I think that's 83. Also greater than or equal to 5. All right, what else do I check? Was it random? Assumed this time, yeah, they didn't tell us. And then what's the new one we're putting in now? Independent. Are we okay on independent on this one? All right, then you just have to go through the same thing for the other population. N sub B times P hat sub B. Times 11. Definitely greater than or equal to 5. Sorry, 118, not 111. And sub b, 1 minus p hat sub b. (200) times 0.41 equals, what do we get there? 82. Also greater than or equal to 5. And then again, are you guys good? The random and independent, essentially the same as the other side. All right. I'm doubtful that I have enough room to fit the rest of it in there, but we'll see. Yeah, how are your hands doing, guys? Okay. All right, are we okay with conditions? We're doing a confidence interval, so let's actually go through our confidence interval. And you would call this a 2-proportion Z interval. All right, let's write out what the mu and sigma would be. But then I'm not going to have you do it by hand from that point. We're going to do this on our calculator because it will do all of it for you. But just to make sure we know what we're looking at. So p hat sub g minus p hat sub b. The mu of that is the 0.605 minus 0.59. You can actually subtract them if you want to, or you can leave it like that. And then our sigma of p hat sub g minus p hat sub b. Again, I'm not going to make you type this one in, okay? But that's going to be square root. Do everything for the girls first, then everything for the boys. So 0.605 times 0.395 over our sample size there was 210 plus 0.59 times 0.41 over 200. You could certainly do that by hand the way we did for the last one, but I don't think you actually want to. So let's get out your calculator. I'll open mine up here. All right, where do you think we're going to start? Where do we go, guys? Stat, yes, good. We're going to go over to tests. We're going to start using some of these other choices in here. So it's not a test, it's an interval, right? So we're going to scroll down to the intervals. It's not just a one sample Z or T. What is it, guys? What am I going to pick? Yep, 2-proportion Z interval. Very good. So go ahead and select that one.
Do we still have to write the formula?
If you name, usually what the scoring rubric says is that it was either the name was stated or the formula was written. Okay, so don't have to do both. Okay, I want to make sure you're familiar with the formula and what all of that looks like. 'Cause you know how sometimes you get multiple choice questions where it's sort of like they've done half of the problem for you, so you can't do the whole thing on your calculator. I just want to make sure you're familiar with those pieces. All right, so you just key in what we know. So the first group we said was 127 out of 210. And the second group was 118 out of 200. We were doing a 95% confidence level, so then we can just calculate it. So much nicer than keying everything else in by hand. All right, if you're not getting negative 0.08 to 0.109, let me know. Question? Yeah.
What do you,
It just showed me this.
which
That lose you with there? Yeah, go to stat, test, and then it's 2 proportions a unit.
which numbers do you want? Like, what are the X1?
So the X1 and N1, that's your first group. So the girls, so what was it,
127.
Thank you. Barely numbers.
Okay.
No, that's how that works. Anybody else? I'm gonna give myself a little more room here. So again, just to make sure you're familiar with the formula for the confidence interval, again, you don't have to do this by hand, but it would have been the difference between the two, so the 0.605 minus the 0.59, and then plus or minus your critical Z. Do you guys remember the critical Z value for 95% confidence?
2.
Close.
1.6.
Low. 1.96. That's okay. And then that is times, if you had done the standard deviation part of it, the sigma of everything, it came out to like 0.048. So just so you're aware of like what's happening with the confidence interval, but we can certainly calculate that on our calculator, and you get negative I can't remember. What was it, guys? Negative 0.109. So 0.11. Are we okay with that? Yeah. Okay. All right. So your conclusion then: we are 95% confident. That the true difference of the proportion we'll make sure we note girls minus boys of Langley students that dress up for Spirit Days is between negative 0.08 to 0.11. That's all you have to say. Okay, do we like the confidence intervals better? I think they're easier than the sampling distribution. Now, let's look at that answer we got. It's from negative 0.08 to positive 0.11. When you're doing difference of proportions, getting negative and positives in your interval definitely matters. What does it mean, the negative part of this interval? Does anybody have any idea? We're talking about proportion of girls dressing up and boys dressing up. What do you think the negative part means, Haley? Yeah, so it could happen that more boys dress up than girls. There's more on the positive end of this interval, but you do have the negative part of it, and 0 being in the middle means maybe the exact same amount dress up. Okay, so this interval is trying to capture the truth. Really, the truth could be girls dress up more than boys dress up more than girls, or it's the same. Okay? So just be aware of that when you see negative and positive values in your interval, what that is telling you. All right, questions on the confidence interval? Okay. Yes. You could. I mean, you could say between negative 8% and positive 11%. That would be okay. Yep. All right. We look so ready for the hypothesis test. Okay. It's the last one we're doing today, guys. All right, so we go back. Yeah.
So for each of the 3 different types of problem, you have to find the mu and sigma of the difference of proportions, even if you're not using those numbers in calculations.
Yes, we did use those numbers in this. Like, I see what you're saying. Like, even if your calculator is doing it for you. Yeah, still list those out so that you're showing, hey, I know where this came from. Okay? Yeah, go ahead. All right, so let me go back. All right, we've got our 2 proportion significance tests happening here. So using the data from our interval we just created, is there significant evidence at the alpha equals 0.05 level that the same proportion of boys and girls dress for Spirit Days at Langley High School? We kind of talked about that already in just the interpretation of that confidence interval. So let's actually go through the whole hypothesis test. Okay, yeah. No, that is the wonderful part of this problem. We do not need to redo all the conditions. It's the same data as above, so we don't have to do that, okay? We do have to figure out what they're asking us to test for and what our null and alternative hypothesis would be. They are asking us about the proportion of girls being equal to the proportion of boys that dress up. Okay? It is. That's okay. I'm sure. Good catch. So we are going to say our null, you could write it P sub G equals P sub B. I'm going to go ahead and write it in terms of the difference because that's how everything else has been so far. We've done P sub G minus P sub B. Our null is that that is equal to 0. What do you think the alternative is going to be?
More girls.
It is two-tailed. It's actually just not equal to 0 because we just want to know, are they equal? Are they not? Yes. So that is your alternative. The difference is not equal to 0. Okay? And again, if you had written it P sub G equals P sub B, and your alternative you wrote P sub G does not equal P sub B, totally fine. Like, absolutely acceptable null and alternative. I don't care which way you write it. Okay, this is a pooling question here, so we can just go through our p-hat pool. All we're going to do is take our 127 and our 118 And I know this looks like horrendous math fraction adding here. You're like, what? That's not how you add fractions. But you're just completely combining the two sets. Okay? We're not actually adding fractions. So we now have a pooled p hat of 245 over 410, which is 0.597. Okay, I'm going to write out the formula that you would use when you're doing this test, but we're not going to do it by hand. I'm not going to plug the values in. We're not going to key everything in. It would take you a while. We'll do the whole test on the calculator, but let's write the formula just to help you guys become a little more familiar with them. So it is p hat sub g minus p hat sub b. That's kind of like your, just in the normal one, just your p hat. Okay, you just got both of them together. When it was one sample, you just did minus p. We now have to do minus p sub g minus p sub b. I know it's a lot of minus signs. And then divided by the whole p sub g minus p sub g over n sub g plus p sub b minus p sub b all over n sub b. We're not going to do that all by hand, okay? Yeah. Let me grab your formula sheet and show you what's on here. Chatting. So, yeah. So yes, guys, they are on your formula sheet. Okay, you've got your one sample and your two sample. So don't panic on your memorizing. All right, so let's go back to our calculator here. Okay, we're going back to stats to test, because we're doing a hypothesis test. What kind of test do you think we are doing? We are two proportion z test, okay? 6, I think.
So if you go to proportion z test on here,
No, but I want you to be familiar with the formulas. Again, a lot of times you'll get multiple choice questions that are sort of like partway through hypothesis tests where you have to recognize what those formulas mean. So that's why we're writing that. All right, my values are already in there because of the confidence interval we did. We want to make sure we pick not equal. And I'm going to pick draw. Is that what you're going to ask? Yeah. I always just like it. Then I can copy the picture and I've got everything I need. That is a lot of shaded area. Yes, that is a huge p-value, right? Yeah, this is the one that you do and you're like, did I mess it up? No, you did not mess it up. But you start to doubt yourself. All right, anybody having troubles with this on their calculator? Okay, all right. Okay, so let's make our sketch then in our problem. Draw your picture. Okay, where is this one centered? What was our null? That the difference was what? It's just centered at 0, yeah. And then was it 0.3, 0.31, something like that? What was the z-score? Okay, so we'll do, this would be 0.3, negative 0.3, sorry, and here's 0.3, we shaded, and we shaded. All right, so we got a p-value here of, what was it, 0.76, something like that? 0.7606, okay. We'll just say 0.76 then. You can tell me that your z was equal to 0.3, 0.304, whatever it was. So what do you think? What are we going to write in our conclusion on this? Yeah, that is a large p-value, definitely greater than 0.05, right? Are you done or you have a question?
Yeah.
Oh, okay, you just said it earlier. Just, yeah. You're good, I promise. All right, so since our p-value of 0.76 is greater than alpha of 0.05, you know, just a little bit greater, we fail to reject the null. There is not enough evidence to suggest that the proportions of boys and girls at Langley dress up for Spirit Day are not equal. All right, I'll let you write that, process it for a second, then we'll talk about it.
What was the way by using?
You could write, let me make sure the way I wrote it. So you could also write E sub G equals P sub B. Okay, and hopefully this makes sense. When we did the confidence interval, remember how it went from negative values to positive values, and we talked about how 0 was included? So there was definitely a possibility that the two proportions were the same. That's what 0 being included in that confidence interval means. And here our null was that the difference was 0. And we did not reject that null. We're saying, yeah, it's very possible that the two groups dress up the same proportion, like the same proportion of them dress up. Does that make sense, like the connection between the two? Okay, you'll see a lot of that with like, oh, was 0 included in the confidence interval? And how that connects to your hypothesis test. All right, questions? How we doing, guys? That's a lot of information, I know. Okay. All right, so we'll stop there. We will do means next time. And guys, this is obviously a unit where we just have to practice it a lot, okay, to get comfortable with all the different pieces that are happening. So we will do